Right, so this is going to be a pretty quick one. I've actually found a better way of detecting a power loss than the one I showed in the previous video. If you haven't seen that, no worries. This is way better, and achieves exactly the same result, exactly as good, just with an insane amount of extra elegance. So all the parts you'll need is a resistor, preferably more than 500 ohms, anything above 500 ohms, and I'd say stick to below 10 kilo ohms, although 1K I found to be best. You also need a tiny capacitor. What I have here is a 47 microfarad. Way lower should be also fine, so everything above like 10 microfarads should work, even less I suppose. And you'll probably also want, but not always need, depending on how many consumers you have on your circuit, a bulk capacitor for the system bus, kind of. Right, so, and this button is just a relic of the past projects that were on this breadboard. So let's very quickly draw this out, just in case it wasn't clear enough. So let me shove shit up. These are the three components. Again, this bulk capacitor is optional, but recommended. And so let's now go to the software. Actually, I should tell you now, right? So the principle of operation is in bursts of 10 milliseconds. And again, all the values have been chosen due to expert judgment. I mean, any value should work, right? But 10 milliseconds I find to be a reasonable amount of time to charge this at, right? So we're going to drive the analog pin high for as long as it takes this to get to 90% of the bus voltage. An analog to digital converter will read its maximum value, in this case 1023, when it reads 5 volts. Again, we assume that this is powered at 5 volts, but again, from USB it's going to be more like 4.5. So if you actually put 5, it's going to overflow the thing, but it's still going to overpower the analog converter, but it's still going to give out that. Right, so 90% of that is 0.9 times is 920. 20.7 is going to give us 4.5 volts. Is it? Yeah, very nice. Yeah. All right. Exactly. So we want to keep this charged up to 4.5 volts, not 5, and you'll see why. And after it's charged, right? So we're going to give it at the start a pulse. It's going to take 600 milliseconds, whatever it's going to take at 5 milliamps to charge a 47, I think it was, microfarad cap. After that, what we'll do is we'll switch this analog pin to an input and read it, right? And we should get, again, 920.7. If we get below 920.7, we're going to charge it. We're going to switch A3 to output and drive it high. And this is going to take 10 milliseconds. This is going to last for 10 milliseconds each step, right? And then the next step, we're going to read it. Is it 920? Okay. Next step, is it 920 or above? Okay. 920 or above? Okay. If it's below, we charge it. So we try to flow charge it to achieve a value of 920.7. If this is 4.5, is completely irrelevant. It could be 3 volts, it could be anything, right? It doesn't matter. The moment we lose power, though, our system voltage is going to go down, right? But this isn't, right? This isn't going to power anything. This is only connected to an analog pin that is either feeding it or reading it. And if it's reading it, it's like 1 mega ohm of resistance. So nothing is discharging this cap, ever. Right? Just its internal resistance, whatever. So the moment the system power goes down, right, this 5 volts that represents 1023 is going to go down, right? Right, so power down I'm good at centering shit. Then 1023, let's say our bus voltage has gotten to 4 volts. Right, so when this bulk capacitor is at 4 volts, reading A3 and seeing 4 volts is going to give us 1023. But remember, this was charged to 4.5, right? So reading 4.5 is going to give us 1023. Exactly, so instead of reading 920 or around 920, we're all of a sudden going to read 1023. And we could, I've set it to above 1000. Right, and the moment we read above 1000, we can save to the EEPROM. So let's reset this. And what I'm doing when the power is lost is I turn the LED on. So check this out. And again. So we're charging the cap now. Okay, so over here you're going to have to include one library, and this is for timer 2. I'm actually using timer 2 in this particular case because I'm using timer 1 for something else. This interface is a bit uglier, but it still does the job. So basically what a timer does in this case, right, so the Atmel 328P, which is used in all the Arduinos, most of them, has 3 counters, timer 0, 1, and 2. Timer 0 is used, for example, for millis, right? Whenever you call millis, this value is computed using timer 0, I'm pretty sure, although, again, don't take my word on anything. So basically what this does is it allows us to set an interrupt every time this timer 2 counts up to a certain value. And what this library does is it makes all of the bit shifting and bit banging and all the setups and everything super elegant, right? So basically what you need to know is this, well, what this does over here is basically saying if millis is equal to 10, pseudocode do shit, right? Call your function, in this case power loss detector, and it'll also, we do have to actually, so it'll also reset, let's just say millis is equal to 0. Basically this is what we're doing here, only this is running completely in the background. Right, this timer is completely independent and is counting upwards, completely independent of what the actual processor is doing. It's doing its own thing in the background, it has its own adder and everything, so it doesn't add any overhead to count up. Right, this counter, if you don't use it, it still counts up. Well, it's probably disabled, but anyway. Exactly, so every 10 milliseconds, we will call this function. And again, don't put the brackets because it's not going to work. So again, pretty weird interface, but again, does the job. So the loop can be empty. You can do your job here, whatever you want. In this case, nothing. And yeah, so if the value that we read from analog 3 is less than 920, which is 90% of the full thing, we're just gonna charge it up, right? So we're gonna set A3 to output, we're gonna set it to high, and we're gonna return. And what this does, even if this function is a void, you can actually call return, right? So you can actually call return 5, and it's not gonna. Can you? All right, so yeah, no. So you can actually call return 5, right? But this is not really advisable inside a void function. What this will do is it'll basically immediately jump here and go out of the function, right? So just end the entire power loss detector function. And we want to do this because we don't want to read the pin immediately after. Well, we don't have to, right? You could actually leave it at that. next time we come here, right? So the next time after 10 milliseconds, this function will be called. Is the cap charged? No. Okay, charge it. Next time, right? At some point, it's gonna be charged, right? And this value is gonna be above 920. Usually hovers about 920, 930. Doesn't go much higher if you charge it for 10 milliseconds, right? In my case, the 47 microfarad cap. So in that case, we read the input, and now we set the analog 3 as an input, and if the value is greater than 1,000, I mean, we surely didn't charge it to more than 1,000, right? The steps, the 10 millisecond steps, are definitely small enough. So it must be that we are going under, right? For us to see this as such a high voltage, we must be at a much lower voltage than we were when we were charging it up, right? And here you can do whatever, right? So here, also, right, given that this is an interrupt function, if you have any variables here, you're going to have to define them as volatile. Int 8ta, for example, right? If you don't do the volatile thing, it might work, but it's going to do weird shit at weird times, right? So just keep that in mind, right? Whenever something is iffy, you probably didn't declare something as volatile. Also, since this is an interrupt, right, this will stop your code, right? So whatever your code is doing, it's going to suspend that and go to here and run this. So you don't want to do delays and all that crap, right? So I hope this helps, and yeah, any questions, leave them down in the comments. Have a good one, guys.